Okay, I'm back today to do another video on the Hoover mods. Behind my little picture over here we have the Hoover block. Right, specifically we're going to be looking at the swivel foot adjusters. Item number one, let's read the Ford Subi type swivel foot adjusters, which act as spray bars. We're going to talk about the spray bar concept. Second, retrofitting modern day engineering. We're going to talk about modern day. And the last little piece, they spread the load on the end of the valve stem, reduce the side loading. So let's get started. So here I am at my kitchen table, and I have some components for testing. And what we're going to test, the swivel foot adjusters, which act as spray bars. So what I want to test today is, do they act as spray bars? Now what I have here is the standard. This is the one that we would typically use. Well, sadly, they don't do what Hoover says. So let me see if I can prove it to you. Alright, it's got a hole in it so that the oil that comes through the rocker can hit that hole. There's also some missing threads, so that if you don't have it directly lined up, or if it's rotated to the side, there is enough space for the oil to work its way around to get into that hole. And then once you go down inside the hole, of course it's drilled from this end to that end. And the oil, of course, will go down through there, and it will come back underneath the ball. And of course, Hoover's thesis is that once it gets past the ball, it works its way around the ball and comes shooting out onto the. Yeah, I know somewhere in there he says it sprays on the spring. It would never ever spray on the spring because it has to go past the retainer first, and it would simply just blast into the retainer, never getting to the spring. We need to put together the assembly in order to get the test done. So let me put the assembly together. Alright, first of all, I don't have any rockers that actually have the cut that goes around in order for stuff to do. But if you look on the end right here, what I have is one of those rare earth magnets. And it's about the right thickness, and when you take it and it just kind of ploink, attaches these two guys together. Then all I have to do is take one of these, slide it down, and I will have a gap of the appropriate size that we can use to push air. I'm not going to do it with oil, I'm going to do it with air. Push air from one side to the other. Alright, so I've got the crack lined up in here pretty well so that it catches the output of this and the input of this one, so that we get some air flowing through. So we take this guy like that, and you should be able to hear this. I mean, this camera's got a lousy microphone, but you should be able to hear that the air is blowing through. Alright, it's going out at the end that I'm talking about. Obviously there's a hole down inside there. You understand that when you put a stock one in, the threads block it up. And one other thing, incidentally, these are from 1974, and one of the things about these 74s, the stock ones, the hole on the end has not been welded shut. You'll see a lot of these have been welded on the aftermarket ones and the newer ones that you buy in kits and stuff like that, but these factory original ones, they weren't shut down. So I have to deal with that a little tiny bit when I do the experiments. I've got it in there. We put the push rod back in, and we try and make some air blow out the system. Now keep in mind now, if I plug this hole up right here, there should be some air blowing out right here and right here. Okay? Let's see what happens. Nothing. So this is what the stock system does. The stock system is not designed to allow any oil to exit the system at all, really. It's bizarre to me that they would have shut it down to this extent. But see, the thing is, when it starts moving, some oil will pass through the system. It'll leak out down in here. But this particular piece of the stock system passes no oil at all. Now, if you go to the Samba, people are going to tell you, oh, it runs past the threads. Not in any appreciable fashion, because I can't get any air to flow out of here. One of the things you have to understand about air is that it's about 500 times easier to flow air through a system than it is to push motor oil through a system. And yeah, I might stick that. I might have to go over to Wikipedia and prove that to you, but yeah, it's about 500 times. Let's take this guy out, and then we'll move on to the swivel foot. All right, I've got this thing lined up pretty well at the moment. If we put air in here, it passes through here without really losing anything, comes over to here. Here's our swivel foot. And then, as I said, this is a 74, which means it's got a hole on the back side over here. Between the hole and coming out here, it's going to go out the hole, but let me show you that it does indeed send some air out the back side. Remember, the stock one was unable to do this. Okay, notice that there was like a change in volume. That's because not all of the air is going out here. You can, if you blow on it, you can push this thing off its seat and air will come out around here. So hang on just a second. Let me do them both at the same time. Now, that's not a lot of pressure, but it is enough to kind of prove my point. Like I say, if air, which is 500 times thinner than oil, passes out at the pathetic nothing volume, kind of like that, the oil's really not going to pass out, even if you jacked up the oil pressure, which happens when you have a dynamic motion. The push rod's going back and forth like this. They pump up the oil pressure. These things actually act as pumps. But hopefully you realize that when I push on this, it stops the air from going out. Which means anytime you're lifting the valve, this is being pushed on. So no oil comes spraying out of it when you're lifting. And when you're on the base circle of the cam, of course you've got lash. And if you've got lash and you blow on this thing, you of course get oil, in this case air, but you'll get oil leaking out down at these places right here. And given the choice of leaking out down here or going up here and leaking out, down here versus up there, it's going to leak out down here. And I'm going to stick a video clip in here which indicates that. Well, I was going to stick in a little video clip at this point, but I found the video originally by looking through the Samba posting over there about the Hoover mod, and somebody came along after my posting and posted a link to a video that they put together of their, I don't know, it was like a 2.3 liter. It was a pretty big motor they put together. They popped their valve cover off after reading what I'd done and then just posted a link to it, and it showed exactly what I've been telling you. No oil coming out here, no oil coming out there. In addition to that, it showed huge amounts of oil hemorrhaging out at the interface, exactly like I said it would. As soon as it goes to lash, oil begins to come out right there. Oh, it was crazy. But anyway, the guy pulled it. He pulled his entire posting from the Samba, so it's not there anymore. And I have been trying now, off and on, for about 2 months to find that video. And it's gone. The guy just pulled every single bit away. I don't know why he did it, but it was absolutely glorious. All I can do is tell you about it and tell you that it indeed supported my claims. So I apologize to you that it's gone. You'd have to trust me. And I hate to do these videos where I say, you need to trust me. It's not really the way I should do it, but at this point, yeah, you got to trust me. I'm not lying to you. Now, the video clip that I do have in here is, again, it's a Hoover modded motor. It's got swivel feet on it. You're going to see a lot of oil coming out up at this end. And the person who put this particular video together, they filed out a notch down in here in order to get oil to show, flow out. And it's a really nice video. It shows that modification in action. It shows that the modification of either putting a hole in here or taking some threads out in fact works, and we'll get you some oil up at the head. So, based on what you just saw with that little video right there, I hope you noticed that the oil was coming out basically when you see it going doink, 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 doink. It's like it comes out as it hits peak lift, peak lift, peak lift. And then the oil at peak lift, if I can draw this here, all right, you push it out. And then the spring returns. And all the oil that you pushed out just goes flying backwards. So what's behind you? I mean, your goal is to put oil in here so that you can cool your head, but it goes out, hits the retainer, and goes that way. Okay, that's not the head back there. That's your valve cover. It kind of shows up. Anyway, I've got this particular piece of baling wire running all the way through here. And this is one of the things I don't like about these little guys. All right, do you see the clearance right there? When you install these on your car, odds are you're not going to install them such that the face of this has that much gap between the rocker arm. So let me turn this in one notch real quick. Hopefully you can see I've turned it one additional notch that way, or one additional thread count that direction. I can still get this in here, but this no longer aligns with the hole that goes over there. It does mean though that you do still get oil passing through, but the problem is some people can't even get their system to line up like this. They then get some kind of a grinder out and they grind the face of this off a little bit. The part of metal that I'm talking about is this little piece right here that this comes from Hoover's blog, and 060, it's about 1.5 millimeters. And if you grind off more than about 1 millimeter and push it down even further, the threads that are on the end of this thing begin to block up the hole that's down there, and then you lose oil. And if you lose oil, this little ball doesn't get any cooling oil, doesn't get any lubrication. It begins to gall, it tears up, it can fall out, then it begins banging on this thing right here, and you just got yourself a big mess. I mean, you have to be careful. I mean, it looks like such a simple little device, but I certainly do not recommend, if you're brand new to the game, do not run these things first off. And if your motor's then working the way you want, then go back and retrofit this thing. But again, this is about Hoover Mod primarily, and it doesn't spray. And in order to get oil to spray out of there, you have to either drill a hole or rip out some threads. Hang on just a sec. Okay, that's not too bad. Alright, so anyway, what you got to do, you either drill a hole right down in here, from there into the little bore that goes this direction, or you can get like a file. This is not the right kind of file, but you could get a file out or a teeny tiny Dremel or something like that. You stick it down in there, and your goal is to take out the threads that sit between that hole and the edge so that you can get some oil to come out. Once you've got the oil coming out, of course you end up with what you saw at the video. You get a nice surge. Every time it goes surge, 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 and it pumps the oil out. Alright, so going back to Hoover, and of course his goal was that he wanted to use this as a spray bar, and it doesn't spray. But what was the purpose of this thing? I guarantee you that the people who engineered these things knew that this was not going to spray oil. He was a mechanic, and this was probably put together by an engineer of some sort. So what were they trying to do? And this kind of comes back to what were things made out of back when they built these things. And these things were put together back in the 50s and 60s. So we're talking 50 years ago now. And what happened between 50 years ago today and now? They kind of discontinued these things. I mean, the elephant foot was on, I think it was a 6-cylinder Porsche from the late 60s. It's one of their overhead cam motors. But you certainly don't find elephant feet on Porsches nowadays. They're not, as he says in one portion of his blog, he certainly says they're found on all modern vehicles. You do not find things like this on modern vehicles. Even a Porsche, those elephant feet, obsolete, beyond obsolete. But what happened was we went from leaded gasoline to unleaded gasoline. Sometime back in the 1970s, with pretty much a complete ending of the leaded stuff back in the 90s. The components that the motor was made of changed. Way back in the 50s and 60s, The valves were made of cast iron. If you took something like this and you smacked it into a piece of cast iron a whole bunch of times, you end up getting mushrooming. This would kind of bend a little bit, the valve would bend a little bit, the clearances would open up, you have to adjust your valves all the time. But when they stopped producing the valves out of cast iron, they started making them out of hardened stainless steel. That reason for these things being inexistent ended. Okay, now I don't want you to take my word for this exclusively, but this is going back to that Revmaster article. I mentioned this before, but I didn't actually like quote anything from this directly, but I want to quote this guy directly today. Down in here where they're talking about lifters and valve seats. So we read, one of the frequently mentioned issues that plagued earlier VW conversions was the persistent, though incorrect, belief that the solid lifters in those engines required adjustment of the valve lash every 25 hours. The truth, discovered after exhaustive research by the Revmaster technicians, is that the original valve seat material was inadequate to tolerate the heat created in the combustion chamber once the displacement grew beyond the Volkswagen factory spec. The hot valves had begun to lift tiny particles of metal from the seats, and that erosion, more properly known as galling, in addition to destroying the efficiency of the combustion chamber, allowed the valve to sit deeper in the head. Of course, as it drops deeper into the head, the volume of the combustion chamber goes up, lowering the compression, dropping the efficiency. So they're right there. Testing proved a loss of about 0.001 of erosion per hour, which is very, very fast. The clearances at the rocker arm would then diminish or disappear altogether, causing some to believe that what was happening was that the valves were stretching. I've heard that many, many times, and I've always doubted it. It's entirely possible that stretching happens on the super high-performance, heavy-duty valve springs, super high heat, like drag race motors, but we're talking about engines here in the airplanes where they're only running like 3,000 RPM. So, yeah, not going to happen with these guys. They don't have the valve springs to stretch. Anyway, we continue reading. It became the common practice and continue to this day on VW engines to still utilize inferior valve seat material. I guess we need to get down here. Anyway, the solution is to use stainless steel valves, which are pretty much used everywhere in heads these days, paired with valve seats with a very high nickel content alloy. And believe it or not, those nickel content alloy seats are absolutely ancient and obsolete. They are, however, better than what was available back in, as they say, 1985. So, and again, this is around the time that you started definitely transitioning out of leaded gasoline. It had to go away. We had to do something to work with unleadeds, and as a result of that unleaded stuff, high nickel content alloy valve seats. Precisely what Revmaster has been doing. It's not just Revmaster. The entire industry has gotten rid of the old crappy cast iron junk that used to be in there. And then they talk about solids versus hydraulics, and that's about the end of it. But, yeah, it's not just me. Alright. This Revmaster dude, he's an old dude. He's been doing it for a long time. But that's it. I mean, it's an obsolete device. It's got no purpose. As far as the Hoover mod goes. If you put a little tiny hole in here and you put a little tiny hole in there so that you get a little tiny bit of oil going out, then you get oil onto both surfaces. So who cares? It's all the same thing. They don't do what Hoover said, and they're obsolete. What does a modern valve train look like? Well, this happens to be a Subaru valve train. Again, it's a pushrod motor. Weird pushrod motor. They continued developing this motor. This is in the United States. Maybe they had pushrod motors elsewhere in the world, but in the United States they stopped in about 1989. This happens to be a 1984. It's the same model of engine, the A81. But take a look at the valve train right here. And you'll see that the adjusting screw is on this end. And then up here at the valve, you've got a foot. So this is a more modern approach to a rocker arm. Here's the Subaru rocker arm again, a little bit different angle. You can see kind of what's going on. But one of the things you need to look at is, like, this is the center of the rocker, the shaft to here versus the center out to there. And you can see that this is a high ratio rocker arm. And a high ratio rocker arm is, once again, it's a component of a a more modern valve train. You see this little hole right here. This is for oil. Push oil up. Of course, you've got to do this. A little bit of oil comes out here, shoots over into this direction. So they are trying to take care of the oil. You can't really see it in the other video or the other pictures. And notice that this is a solid spaced shaft, that it doesn't have a bunch of wavy washers and stuff like that. Okay, let's take a look at another motor that uses a screw type. There's our screw. Here's our rocker arm. This happens to be an overhead cam motor. It uses a screw type at the valve end. So this, again, a more modern approach. The rocker arm, if I can show it there, is ratio. It's a higher ratio. And they just stick a screw. This happens to be a Toyota motor. They continued producing this particular motor up until 1997. So that's about 25 years ago. And all you got is a screw. There's no elephant foot. And this is a Toyota. This is, this is a 200, 300,000 mile motor here. And here's the elephant feet from Porsche 911. Really nice looking stuff here. Very expensive. So this is a cut through on the motor. See the valves. Here's your camshaft. Overhead cam. And there's your elephant foot right there. And Porsche doesn't build the motors like this anymore. Again, obsolete technology. These happen to be the latest and greatest factory rocker arms from a V8 pushrod motor, the LS7. If you look right down in here, one, you're not going to see wavy washers and springs and stuff like that. Circle it into place. And inside here, you will not find a bushing. You will find needle bearings. It is, however, stock application. I know a lot of the high-performance guys take the needle bearings out and stick in the bushing. It's great. The needle bearings are fantastic for stock. I run needle bearings in my old 74 2-liter. It's got needle bearings, but I'm not a high-performance guy, so they lasted the entire time. Never tore up, ran fine. But anyway, take a look. From here to there, and from here down to here, it's extremely high ratio. I think these things are 1.8 to 1 ratio rockers. That's what is done in a modern rocker. So there's not much happening. This doesn't move very far, and you get a really high lift. And again, the tip, there's nothing. So this is what is done in modern pushrod motors. Get that Hoover stuff out of your head. Anything that you do with that old VW stuff, it's an antique. It's 1930s, 40s, 50s, whatever. You want to move into the late 20th century, early 21st century, this is where you head. High ratio with no mass down at the tip. Obviously, you can get something that looks kind of like that Corvette stuff from, let's say, SCAD. This, I believe, is a 1.3 to 1 CV Performance, a 1.4, 125. I'm not sure what that is. This is a AA. I think that's a 1.4. Here's a AA 125. I think you can get MP stuff as well. But you'll notice something that you get with these that you do not get with the factory stuff. Right down in here, look at that. Big, bad, beautiful brass bushing. See, the thing about brass is it moves heat about 3 times faster than steel. So one of Hoover's reasons for doing his mod was, of course, to get rid of galling down in this area. But galling comes from too much heat. How do you get rid of the heat? Stick it into a nice brass bushing, and it flows out. So take a look at that. That one's got it. Brass bushing in there. These guys have got it. It doesn't say it in the picture, but they've got it. Just go back and do a little research on them. So that's it. You can get semi-modern technology. This is what it looks like. It's not a swivel foot. So there's one more piece left, and it's called friction. And I've gone ahead and measured the face of this to be about 6¼ millimeters. It will, of course, fit right across the top of that valve right there if you're very, very careful with it. And you could do the experiment yourself that I'm going to kind of do here, which is just kind of scrape it around a little bit, get yourself a feel for what it feels like. Okay. Now let's take a look at some of the math that ultimately results from this. Okay, as I said, I measured that circle to be 6¼ millimeters. That gives it an area of about 31, roughly. The number of square millimeters in an inch, because I want to take this into pounds per square inch because we all kind of understand that a little bit more intuitively. 645 square millimeters per square inch. The area of that little ball in square inches, then, it's about 0.048 of a square inch, or about 5% of a square inch. Now, if you take a valve spring and you go to press it open, Like if I were to try and press this one open, I might have to push on it with about 100 pounds. Okay, that means that the pressure needed here between these two, 2,103 pounds per square inch. Now, what I'm trying to tell you at this point is that given the amount of pressures that exist at that point, and that's not even including the dynamic loads. Well, the dynamic loads would obviously drive this up even higher, but there's not going to be any oil at this interface. This is a dry metal-on-metal sliding friction. And actually, in my own little experiment right here, if I go like this, and I take the stalker, which fits on that end, and I rub my stalker like this, I think that the stalker actually feels like it has less friction than this guy. Okay, so back here we've got Wikipedia. This particular thing is sliding motion. This is the kind of friction that we have going on at the tip of the valve. And right here we have a formula which will tell us how much the friction is. The only thing that it depends on, it's variable in our case, is this normal force. That normal force is the force that it takes to open the valve. So whether you spread it out or whether you keep it at a point, it doesn't matter. It's still the same force. And since the force is the same, that means all frictions are the same. That's going to be the amount of friction that sits at the interface between that ball and the tip of the valve to the valve guide, all the same. Makes no difference whatsoever. Okay, so we're pretty much done at that point, but oftentimes I gripe about Berg and some of his positions on various things, but in this particular case, he's correct. So let us read Berg's thoughts. The part in blue. The greatest benefit is that the high ratio rock arm allows reducing the camshaft lift, ramp angle, and the acceleration rate of the camshaft, and the amount of side load over the distance the lifter must travel. This improves the tracking capabilities of the lifter and produces much smoother operation of the entire valve train. Lifter bore hole wear is reduced. He's got other things in there that are good. So we're nearly done, but we need to take another look at what he says right here. They spread the load on the end of the valve stem, reducing side loading. I'll focus on what he says there. They spread the load on the end of the valve stem. What you need to interpret from that is that he's not putting that ball, that round face, off to the side. He's putting that ball on the end of the valve stem in order to spread the load. He's not setting the valve train up specifically like he would with a stalker. So let's take a look at how he sets up the stalker. The point of contact between the adjuster and the valve stem is offset toward one edge of the valve. Actuating the valve in that fashion causes it to rotate, ensuring a good seal against the valve seat. He's not, when we come back over here and we say guides don't wear out nearly so fast if you're running swivel feet, he's not putting the valve adjuster into play the same ways. He's not comparing an apple to an apple. He's sitting here and he's comparing an apple to an orange, telling you that it's an apple to an apple and that this apple's better than that apple. Number two, you're not going to be able to rotate the valve. So here's an airplane guy, Volko, this dude right here. This is very recent, January 4th of 2022. That's only a few months back. He's got an Aero V engine, and that they tell you to take this ball and stuff it off to the side so that you rotate the valve. And so this poor guy is suffering as a result of setting it up according to the way the Aero V guys told him. We read the Ford Courier type, which have a captured ball with a flat ground on it to contact the valve stem. I set them up according to instructions, and that's the Aero V instructions, and after 40 hours, there's zero evidence of rotation. Okay, the airplane guys do not do what's called the Italian tune-up. They don't rev the snot out of their motors. If you don't rev the snot out of your motor, you're never going to get enough energy passing through the system to get it to turn. So he now takes out his Ford Courier types. Remember the date, January 4. He's now at February 2nd, so this is about a month later. Now, if I could only get the valves to rotate as intended with the original VW valve adjuster. So he's gone. He can't get rotation with the foots. He can't get rotation with the stalker. So we just heard from that guy. There are other people in the flying forums that I found that have also claimed, I'm getting no valve rotation. That's anecdotal evidence. I've got a video that's about 20 minutes long that tells you physically why it will not rotate the valve. What happens when you take the screw and you put it, off center? obviously, the valve is going to be, of course, held in place by the guide, and it's going to try and twist inside the guide, something like that. But if you push down in the middle, it doesn't twist as much. So if you push off to the side, you're going to get bigger wear. Guides don't wear out nearly so fast if you're running swivel feet, but as I said, he doesn't ever tell you in any of his writings to go out and put the ball off to the side. So what I'm telling you is that you would never take either adjuster and put it off center on the valve. I'm not the only one who thinks like this. There is a well-known VW guy who's got an entire video on it, and let's take a real quick look at who that particular video guy is. It happens to be vwdarrin, and the video is VW Rock Arm Geometry How To. In this video, Darren's going to tell you to take your adjusters and put them down the middle of the valve. And in so doing, you're going to lessen your valve guide wear. He is correct in telling you to do this. It's interesting. Read the comments. There are plenty of people down there that are telling him, no, you put it off to the side in order to rotate the valve, and you can't rotate the valve, not by putting it off to the side. He is correct. Well, I need to end this video at some point, and I suppose what I'm saying is that this is not a performance item, but then again, neither is the stock one. If you look at them kind of like that, you can pretty much tell that this is going to be heavier than that, and if this is heavier than that, then this is clearly not the performance item. But the real gain that you get is by abandoning this entire format. On the other hand, are you really going to gain anything significant by going the other direction? It depends. I mean, for us, given that my channel is basically about extended stock and high MPG, when you're staying around 5,000 RPMs peak, it's not going to make a big difference to go to the other stuff. But yeah, the benefits are there, even in a stockish format. Anyway, continuing on, I stand by what I said. The amount of friction that you get here is basically the same as what you're going to get with the other guy. No frictional difference. Put this guy up there, it's not going to spew any oil unless you poke a hole in it. And I mean, if your adjusters are worn out, you could certainly pick up a set of them. I mean, just look at the price. It's like 33 bucks versus 35. So they're even cheaper than the stock stuff. So why not pick a set up? Maintenance is a little bit easier. At least I always found them to be a little bit easier. You just get in there, and when it comes time to adjust them, the weird little things that you get on here make it a little bit more difficult. You can read about that at the SAMA. There's plenty of people that tell you, oh yeah, they're easier to adjust. Even Hoover claims they're easier to adjust, and he's right. But for my car, I don't have to deal with it. So, although they were in the prior iteration, they're gone now because these are lighter. I thought it was a pretty thorough review. But like I said, it's got to end at some point. Got one more piece I need to do with that Hoover mod stuff. It's enough for now.